Welcome to the I Can't Sleep podcast, where I bore you to sleep with my soothing voice, one fact at a time. I'm your host, Benjamin Boster. Tonight, let's fall asleep learning about Cummins, Inc. Cummins, Inc. is an American multinational corporation that designs, manufactures, and distributes engines, electric vehicle components, and power generation products. Cummins also services engines and related equipment, including fuel systems, air handling systems controls, filtration, emission control, electrical power generation systems, and engine control units. Headquartered in Columbus, Indiana, Cummins sells in approximately 190 countries and territories through a network of more than 600 company-owned and independent distributors and approximately 7,200 dealers. The Cummins Engine Company was founded in Columbus, Indiana on February 3, 1919. by mechanic Clessie Cummins and banker William Glanton Irwin. The company focused on developing the diesel engine, which was invented 20 years earlier. Despite several well-publicized endurance trials, it was not until 1933 that their Model H engine, used in small railroad switchers, proved successful. The Cummins N-Series engines became the industry leader in the post-World War II road-building boom in the United States. With more than half of the heavy-duty truck market using Cummins engines from 1952 to 1959. In the 1960s, the company opened an assembly plant in Shotts, Scotland, closed in 1996. By 2013, Cummins had operations in 197 countries and territories. Cummins' component business unit consists of emission solutions, filtration, fleet guard, fuel systems, turbo technologies, Holset, and electronics. The Cummins Turbo Technologies unit designs and manufactures turbochargers and related products on a global scale for diesel engines above 3 liters. Its emission solutions unit develops and supplies catalytic exhaust systems and associated products to the medium and heavy-duty commercial diesel engine markets. Cummins Filtration designs, manufactures, and distributes heavy-duty and light-duty air, fuel, hydraulic, and lube filtration, chemicals and exhaust system technology products for diesel and gas-powered equipment. In contrast, Cummins Electronics designs engine control units and sensors for Cummins diesel engines. Cummins Engine Business Unit consists of aftermarket support, mid-range, heavy-duty, and high-power engines. Its markets include heavy and medium-duty trucks, buses, recreational vehicles, RVs, light-duty automotive, and several industrial uses, including construction, mining, marine, oil, gas, railroad, and military equipment. One of the most popular engines built is the 5.9-liter I-6 engine used in the Dodge Ram heavy-duty pickups starting in 1988. In 2007, a 6.7-liter version of the Cummins straight-six engine became optional on the Ram pickup. In 2008, Cummins was a named defendant in a class action suit related to 1998 to 2001 model year Dodge Ram trucks, model 2500 or 3500, originally equipped with a Cummins ISB 5.9-liter diesel engine, built using a pattern 53 block. The case has been settled, but some qualified Chrysler owners may receive $500 for repairs to the block, which was alleged to crack and create a coolant leak. In April 2013, Cummins utilized technology developed by Westport Innovations to ship large natural gas-fueled engines to truck manufacturers in the United States as trucking companies began converting portions of their fleets to natural gas, and the natural gas distribution network in the United States began to expand. Cummins has a technical center in Darlington, England, for developing products for the European, Middle Eastern, and Asian markets. Cummins' distribution business consists of engine and power generation distribution, as well as service and parts. The distribution unit of Cummins consists of 17 Cummins-owned distributors and 10 joint ventures, covering 90 countries and territories through 234 locations. Cummins Power Systems business unit consists of alternators, automatic transfer switches, commercial power systems, consumer systems, engines, and paralleling systems. All of the above stem from the Cummins Onan Corporation, whose products remain in service today. This business unit was formed recently, following a merge of the power generation unit and high horsepower subdivision. On August 22, 2017, United Rentals announced it had acquired all mobile power generation assets from Cummins. To maintain fleet and customer service continuity, some Cummins employees joined United Rentals. On March 8, 2023, Cummins rebranded its new power business unit as Accelera by Cummins. Accelera provides zero-emission solutions, including hydrogen fuel cells, batteries, e-axles, traction systems, and electrolyzers. The Holcid Engineering Company was a British company that produced turbochargers, primarily for diesel and heavy-duty applications. In 1973, the company was purchased by Cummins after briefly being owned by the Hansen Trust. Holcid now operates facilities in China, India, Brazil, the Netherlands, the United Kingdom, and the United States. In 2006, the division officially changed its name to Cummins Turbo Technologies to be identified more closely with its parent company. The turbocharger products still use the Holcid brand name. Plessy Cummins invented the engine brake in the late 1950s and sold the technology to Jacobs Chuck in 1961 for production, which created the Plessy L. Cummins division of the company to produce engine brakes as an aftermarket option for various diesel engines. This division would later separate from its parent company and be known as Jacobs Vehicle Systems from then on. The company would be purchased by Cummins in 2022. The division has manufacturing facilities in Bloomfield, Connecticut, as well as Suzhou, China, and although it is no longer known as Jacobs Vehicle Systems, Cummins still uses the Jacobs name for its engine braking products. The company also designs and manufactures multiple variable valve actuation technologies for heavy-duty applications. In 1986, Cummins began the acquisition of Onan and completed it in 1992. Since then, Onan has evolved into Cummins Power Generation, now Cummins Power Systems, a wholly invested division of Cummins. The Onan name continues to be used for modern versions of their traditional engine-driven generators for RV, marine, commercial mobility, home standby, and portable use. Cummins, Inc., New York Stock Exchange, CMI, announced that it will be unifying its brand strategy across its power systems business segment, which provides high-speed engines from 760 to 4,400 horsepower and power generation equipment from 2 to 3,500 kilowatts, including standby and prime power gensets, alternators, switchgear, and other components. Currently, the portfolio features the Cummins, Cummins Power Generation, and Cummins Onan brands. With immediate effect, the branding will be consolidated under the Cummins brand. The Cummins Power Generation and Cummins Onan brands will be retired, and the Onan name, synonymous with mobile gensets, will be repositioned as a generator product line under the newly unified Cummins brand in the RV market. Cummins, Inc. will also be permanently changing all Fun Roads branding to Cummins RV, moving forward as well, and the Fun Roads brand will also be retired. As Onan will now be repositioned as an RV product line, with the new website and social media platforms serving as tools for RVers across the country to find relevant information, like product specs, and a sales and service locator. Looking to unify Cummins into one cohesive, unified brand, we decided that consolidating both products, engines and generators, into the Cummins RV family only strengthens the brand and more uniformly speaks to our manufacturers and consumers, said Jody Wilson. The brand changing will not affect product or service offerings, but will help us to continue on our promise of delivering dependability across the globe. Rebranding occurred globally on all marketing activities, as product branding changed across all manufacturing plants beginning July 2017. Exhaust and emissions after-treatment company Nelson Industries was purchased in 1999, due to the increasing importance of exhaust after-treatment systems for meeting future emissions standards. The division changed its name to Cummins Emission Solutions to be identified more closely with their parent company. Cummins has some joint ventures with Chinese manufacturers, such as Dongfeng Cummins, a joint venture with Dongfeng Automobile Company, as well as Guangxi Cummins Industrial Power with Liu Gong. One of the most successful joint ventures is the joint venture with Foton called Beijing Foton Cummins Engine Company. This joint venture developed the ISG X12 engine platform in the mid-2010s. The ISG X12 in China has surpassed 240,000 units per year, making it the highest volume heavy-duty engine in the Cummins product line. The ISG X12 is the foundation for all Cummins future engine platforms. Cummins India is the Indian subsidiary of Cummins. It's publicly traded on the Bombay Stock Exchange, BSE, and the National Stock Exchange of India, NSE. Cummins began its India operations on the 17th of February 1962 in a joint venture with the Kirloskar Group. The ownership structure of the joint venture was divided as follows: Cummins 50%, Kirloskar Group 25.5%, retail investors 24.5%. In 1996, Cummins Inc. bought Kirloskar shares. Now it is a Cummins Inc. subsidiary. As of 2013, the Cummins Group had revenues over $1.5 billion, 20 factories, and 9,000 employees in India. Cummins conducts a significant part of its R&D in India at the Cummins Research and Technology Center that was established in 2003. Cummins has built a technical center in Pune, which houses over 2,500 engineers, called CTCI, Cummins Technical Center, India. Cummins India has made significant contributions to local skill development by establishing the MKSSS's Cummins College of Engineering for Women, a women-only engineering college in Pune. The Cummins corporate office building in Columbus, Indiana, is a modernist office building designed by Kevin Roche. Constructed in 1983, the building serves as the corporate headquarters of the Cummins Engine Company. It was constructed on an old railroad yard and is unique for being built around the serial line building, which was Cummins' first factory building. Cummins CEO J. Irwin Miller had a lifelong interest in architecture, and in the 1950s established a foundation to pay architecture fees for new public buildings in Columbus and Bartholomew County. When Cummins decided to construct a new corporate headquarters, it turned to Pritzker Prize-winning architect Kevin Roche. The building is built on a 3-block plot of land that formerly served as a rail yard in downtown Columbus. As part of its distinctive construction, Roche built the new precast concrete structure around the original serial lane building, which served as Cummins' first factory and administrative offices. The original building was also renovated to serve as the cafeteria for the employees of the company. Roche used precast concrete and glass as his primary building elements in the 200,000 square foot building. Jack Curtis executed the landscaping for the facility, including the large open green area on the eastern side that is open to the public as a park. As of 2013, it remained in use as Cummins corporate headquarters. In 2017, Cummins began a $50 million renovation of the building, scheduled for completion in 2019. As part of the construction, Roche incorporated a Rudolf de Harrach sculpture, known as the Exploded Engine, in the lobby of a building. The diesel engine, named after the German engineer Rudolf Diesel, is an internal combustion engine in which ignition of diesel fuel is caused by the elevated temperature of the air in the cylinder due to mechanical compression. Thus, the diesel engine is called a compression ignition engine, CI engine. This contrasts with engines using spark plug ignition of the air-fuel mixture, such as a petrol engine, gasoline engine, or a gas engine, using a gaseous fuel like natural gas or liquefied petroleum gas. Diesel engines work by compressing only air or air combined with residual combustion gases from the exhaust, known as exhaust gas recirculation, EGR. Air is inducted into the chamber during the intake stroke and compressed during the compression stroke. This increases air temperature inside the cylinder so that atomized diesel fuel injected into the combustion chamber ignites. The torque a diesel engine produces is controlled by manipulating the air-fuel ratio. Instead of throttling the intake air, the diesel engine relies on altering the amount of fuel that is injected, and thus the air-fuel ratio is usually high. The diesel engine has the highest thermal efficiency of any practical internal or external combustion engine due to its very high expansion ratio and inherent lean burn, which enables heat dissipation by excess air. A small efficiency loss is also avoided compared with non-direct injection gasoline engines, as unburned fuel is not present during valve overlap, and therefore no fuel goes directly from the intake or injection to the exhaust. Low-speed diesel engines, as used in ships and other applications where overall engine weight is relatively unimportant, can reach effective efficiencies of up to 55%. The combined cycle gas turbine, Brayton and Rankine cycle, is a combustion engine that is more efficient than a diesel engine, but due to its mass and dimensions, is unsuitable for many vehicles, including watercraft and some aircraft. The world's largest diesel engines put in service are 14-cylinder, two-stroke marine diesel engines. They produce a peak power of almost 100 megawatts each. Diesel engines may be designed with either two-stroke or four-stroke combustion cycles. They were originally used as a more efficient replacement for stationary steam engines. Since the 1910s, they have been used in submarines and ships. Use in locomotives, buses, trucks, heavy equipment, agricultural equipment, and electricity generation plants followed later. In the 1930s, they slowly began to be used in some automobiles. Since the 1970s energy crisis, demand for higher fuel efficiency has resulted in most major automakers, at some point, offering diesel-powered models, even in very small cars. According to Conrad Reif, 2012, the EU average for diesel cars at the time accounted for half of newly registered cars. However, air pollution and overall emissions are more difficult to control in diesel engines compared to gasoline engines. So the use of diesel engines in the U.S. is now largely relegated to larger on-road and off-road vehicles. Though aviation has traditionally avoided using diesel engines, aircraft diesel engines have become increasingly available in the 21st century. Since the late 1990s, for various reasons, including diesel's inherent advantages over gasoline engines, but also for recent issues peculiar to aviation, development and production of diesel engines for aircraft has surged, with over 5,000 such engines delivered worldwide between 2002 and 2018, particularly for light airplanes and unmanned aerial vehicles. In 1878, Rudolf Diesel, who was a student at the Polytechnicum in Munich, attended the lectures of Carl von Linde. Linde explained that steam engines are capable of converting just 6 to 10% of the heat energy into work, but that the Carnot cycle allows conversion of much more of the heat energy into work by means of isothermal change in condition. According to Diesel, this ignited the idea of creating a highly efficient engine that could work in the Carnot cycle. Diesel was also introduced to a fire piston, a traditional fire starter using rapid adiabatic compression principles, which Linde had acquired from Southeast Asia. After several years of working on his ideas, Diesel published them in 1893 in the essay Theory and Construction of a Rational Heat Motor. Diesel was heavily criticized for his essay, but only a few found the mistake that he made. His rational heat motor was supposed to utilize a constant temperature cycle with isothermal compression that would require a much higher level of compression than that needed for compressing ignition. Diesel's idea was to compress the air so tightly that the temperature of the air would exceed that of combustion. However, such an engine could never perform any usable work. In his 1892 U.S. patent, granted in 1895, number 542846, Diesel describes the compression required for his cycle. Pure atmospheric air is compressed, according to curve 1-2, to such a degree that before ignition or combustion takes place, the highest pressure of the diagram and the highest temperature are obtained, that is to say, the temperature at which the subsequent combustion has to take place, not the burning or igniting point. To make this more clear, let it be assumed that the subsequent combustion shall take place at a temperature of 700 degrees. then in that case, the initial pressure must be 64 atmospheres, or for 800 degrees centigrade, the pressure must be 90 atmospheres, and so on. Into the air thus compressed is then gradually introduced from the exterior finely divided fuel, which ignites on introduction, since the air is at a temperature far above the igniting point of the fuel. The characteristic features of the cycle, according to my present invention, are therefore increase of pressure and temperature up to the maximum, not by combustion, but prior to combustion by mechanical compression of air, and thereupon the subsequent performance of work without increase of pressure and temperature by gradual combustion during a prescribed part of the stroke determined by the cut oil. By June 1893, Diesel had realized his original cycle would not work, and he adopted the constant pressure cycle. Diesel prescribes the cycle in his 1895 patent application. Notice that there is no longer a mention of compression temperatures exceeding the temperature of combustion. Now it is simply stated that the compression must be sufficient to trigger ignition. 1. An internal combustion engine, the combination of a cylinder and piston, constructed and arranged to compress air to a degree producing a temperature above the igniting point of the fuel. A supply for compressed air or gas, a fuel supply, a distributing valve for fuel, a passage from the air supply to the cylinder in communication with a fuel distributing valve, an inlet to the cylinder in communication with the air supply and with the fuel valve, and a cut oil, substantially as described. In 1892, Diesel received patents in Germany, Switzerland, the United Kingdom, and the United States for a method of an apparatus for converting heat into work. In 1894 and 1895, he filed patents and addenda in various countries for his engine. Diesel was attacked and criticized over several years. Critics claim that Diesel never invented a new motor, and that the invention of the diesel engine is fraud. Otto Köhler and Emile Capitan were two of the most prominent critics of Diesel's time. Köhler had published an essay in 1887 in which he describes an engine similar to the engine Diesel describes in his 1893 essay. Köhler figured that such an engine could not perform any work. Emile Capitan had built a petroleum engine with glow tube ignition in the early 1890s. He claimed against his own better judgment that his glow tube ignition engine worked the same way Diesel's engine did. His claims were unfounded, and he lost a patent lawsuit against Diesel. Other engines, such as the Ackroyd engine and the Brayton engine, also use an operating cycle that is different from the diesel engine cycle. Friedrich Sass says that the diesel engine is Diesel's very own work, and that any diesel myth is falsification of history.